for joining me once again in another exciting tutorial of physics. This is your tutor, the science guru, Mr. Muvyanda. Come with me as we learn. Now, listen to this, guys. Are you writing this year? Are you writing July exams, GCE? This is the information that you need. I'm looking at a very important topic, Hooke's Law. This topic comes year in, year out. So enjoy the lesson. We are looking at Hooke's law. So what does Hooke's law state? So it states that the force needed to extend a spring is proportional to that distance. You're going to understand this when I illustrate. So now, the formula for Hooke's law goes that the force of the spring is equals to K. K represents the spring constants and X represents the extension force. Are we okay? Fx spring force, K spring constant, and X is a spring extension. Now, what does this mean, guys? The force needed to extend a spring is proportional to that distance. Now, let me give you an illustration here. Let's say you've got two springs suspended. You've got a spring suspended on. So this is your spring, guys. This is your spring. Yeah. So this spring, it has a length of 12 centimeters. I see. Now, after adding a mass to this spring, you have added, let's say we add a mass to this spring, it was extended. It was extended. We're trying to interpret Hooke's law. It was extended up to this, and the mass that you added was, this is 12 newtons. Is this making sense, guys? Is this making sense? Okay, let us change it. Let us change the length. Let the length become 16. And the extension, after extended, it went up to 21 centimeter. Okay? So, now, Hooke's law, remember it is saying the force needed to extend a spring is proportional to that distance. Now, I want us to interpret this now. Now, guys, sometime in the exam, we're going to tell you to say, find one, the extension of the spring, Okay, we're trying now to find the extension of the spring. So go on your table, we're trying to interpret and find this. Go on your table. This, it ended up to here. Have you seen? So after they extended, it's like this part was the extension. This part, the x was the extension. So how do we find this x? We can say that x, we just find the difference between 21 and 16. We say 21 centimeter minus 16 centimeter. You are going to get 5 centimeters. Are you okay? 5 centimeters. Now, the next thing we are going to ask you in the exam is to find the spring constant. Find the spring constant. Now, how do you find the spring constant, guys? So remember, before you do anything in physics, you need to collect what we call the data. Okay? The data. Now, get this general equation. Spring force, for the force of the spring is equal to the constant over the extension. Now, we are trying to make the constant the subject of the formula. Divide both sides by x. Divide both sides by x. And this goes, x will go, and this will go. Are you with me, guys? Follow me well. This is for your exam. Follow me well. Then you say, your K is equal to the force spring over the extension. Then you get your data. Now, you say data, you have the K, you're trying to find the K, then the force of the spring, they've given you to be what? 12 newtons. Remember that if this force let's say this was, if this force, it was in grams, you can say that weight is equal to mass over gravitation. Now, I want you to take note of this again. For a spring in equilibrium, the tension force, so the tension force at the other side, okay, and the tension is equal to mass over gravitation. Take note of this. For a spring in equilibrium, the tension force will act the other side, the opposite direction of the force. And this equilibrium, you're going to notice that the tension is equal to mass over what? Tension equals to mass over the mass times gravitation. Then, if you're trying to convert this, let's say it was given in kgs, just say mass times gravitation. You have the Newton. Take note of those important points. Then you come, you say x. What is your x? Your x is 5 centimeters. Then you come here, you say, okay, I have my force, the force of the spring I have, which is 12 newtons. I'm even putting the SI units. Then I have the extension, which is 5 centimeters. I say now, what is my spring constant? You get your calculator. Once you get your calculator, you say 5 into 12. You're going to get 2.4 Newton per centimeter. Just like that. Guys, just like that, you have interpreted Hooke's law,